Hello and welcome back. Let's suppose that we have a garden which is located far away. We need a solution in order to control a system which is monitoring and also controlling some actuators in order to irrigate or monitor some parameters for this garden. In this video, we will explore a solution based on the SIMcom chip series like 800 or 900 series, which is also applicable for the newer versions, but we will keep this 900 series as an example in order to explore a little bit how we can communicate via a SIM card using the GSM network. Basically, what we try to achieve is to send a message, receive a message, and also get some time zone information, which will be used later in the microcontroller in order to build an automated system used to control and monitor this garden. So let's start. We need the following hardware equipment. First, we need the USB to UART adapter, and also we need a SIMcom module itself. Of course, these SIMcom modules needs to have already inserted a SIM card, a functional one, of course. Next, the wiring diagram, it's like presented in the image. The yellow TX from the USB module goes to the SIMcom module RX, and the orange one RX from the USB adapters goes to the TX from the SIMcom module. Then we have the ground, which is the white wire. Then also we will have connected the power, which is at 5 volts, the purple wire. Having this wiring, we'll be able to start exploring some basic AT commands and check if the chip is alive, and also try to transmit and receive a message like I already mentioned. So the next step would be to connect the module. The LED will blink every 1 second until the module is in normal operation, and the module is registered to the GSM network, and the module is ready to communicate. The LED will blink every 3 seconds. This will tell us that the module is ready to be used. Okay, and now that we already connected the device, we should be able to open a communication channel and transmit some commands and see what happens. Of course, while you will initially set up your device, you can encounter some other problems, but I highly suggest you to check the datasheet SIM800 series or 900, which will give you a complete list of the AT commands. Of course, here I will present only some basic sequence commands which I already succeeded in running. So basically I'm using here the Hercules setup utility and have COM4 used as a port, and the baud rate is also set. the data size and the parity, and so on. Basically, the simcom module should automatically detect the configuration and use some basic UART configuration, like you can see here. Good, so we will open a connection, and first command that I highly suggest you to use is to check the chip, basically. So we will write an AT followed by a carriage return. So you will need to type a carriage return, which is in ASCII table a 0D. Okay, we already see here that we have an OK, meaning the chip responded with OK, I'm alive. We basically have here doubled because it's in echo mode, but we do not care now about this mode. What we care is about that we get returned an OK. Good. So to, let's say, get the current time, we shall use an AT command, AT plus CLTC equals 1. This command will enable the GSM module to get the time from the network. Once the GSM module is powered up, just to be patient, because this can take a little time, so you need to power up the device, and then the module will return the time zone from the GSM network. This is very important if you want to use this module within a microcontroller and you want to have a scheduled calendar implemented and so on. So we will run this. So I forgot. Okay, so we took it. I got an error first, but it returns okay. Then I will get also the time. AT plus CCLK question mark, then carriage return. Yeah, so basically this is the current date. We have the hour, we have the minutes, and we have the seconds. If we run this multiple times, we will get an update. See, 0, 2, 7. So it will return okay. Good. So this is a basic command which will be useful in an automated system. Next, we can read a message. If let's say our SIM card holds a message, we can read with the following command. I will check the chip. Okay, it's okay. Then we will have AT plus CMGR equals to 1. So basically we will read the first message from the inbox. Yeah, and again we need to carriage return sent. Yeah, so basically we have a lost call. Yeah, and let's read the second one. Yeah, good. So basically it works to read the inbox. This will be useful, of course, if you will establish a protocol between the sender and receiver. Let's say like a comma separate values message, and basically you will interpret those values inside a microcontroller and establish a command basically based on this message. So it should be a common language between the sender and the receiver, but this will be developed later on. Now, if we want to write a message, let's see. Basically, let's check again. So I will always check if the chip is alive and well. And then we should AT plus. So basically now we will try to send a message, to transmit a message. Plus CMGS equal. So we need to enter now the phone number. So this is a dummy phone number which I can use. 801213. Okay, so with this I can create a new message. So 0748 40801213. Okay, followed also by 0D, and now I need to write the message. Basically I can write hello GSM okay, and send it. Good. Now to actually transmit the message, I need to invoke the transmit message via AT and 1A, it's an escape character. Good. Now the message was transmitted. So basically this is all that we need to do to transmit the message, and it's very important to transmit the AT1A, which is a substitute ASCII table character. Okay, so using these three commands should be sufficient to start controlling some parameters for the already presented application, like a garden or whatever system we are trying to build without internet or without any special connections, and basically these modules are quite cheap and enough for this small application. Thank you very much and bye.